Thank you for braving the Bangalore traffic, but especially the traffic in Dairy Circle, whoever did that, to be here on time. Thanks for the introduction, AIM team. So I'm going to be talking about something today which I feel is sort of bubbling under the covers right now. You're not seeing a lot of it, but by the time this year ends, you are going to see more and more of it. So I'll start by asking you a question. How many of you have talked to your phones or a device at home today? Right? How many of you have talked to an application on your computer today? Okay, a much smaller number. But that's what I'm talking about. That, sorry, can I get a clicker or something to progress the slides? Do we have that? So that's what I'm talking about. Is I feel that the time is near where we will be able to more and more be able to talk to applications, right? Like, seriously, I mean, first thing we want to know in the morning when we open our mail ki boss ne kuch bheja kya? Right? So why can't I just ask that, right? Instead of having to sort of scroll through 100 emails to figure out which ones are most important that I need to respond to. But I think that's the whole point that we'd like to head to. That's how we logically interact with things in the world, right? We know what's important, we ask for it, and we get it. And that's why the apps that we use on our phone, which are the most popular, allow us to interact with them in the same way. All right. Quick show of hands. Anybody here has ever worked on a mainframe application? As expected, probably very few. So when I started my career, I used to access email on a mainframe, right? IBM used to have, my first job was with IBM, and IBM used to have this application called Profs. Anybody here heard of Profs? No? So it used to look a lot like this, right? What you see over here on the top left-hand side. And it wasn't even like the applications we built as children in our schools where you give a menu, you all remember that? When we did computer science, first computer science course that we did in school or college, they used to teach us how to write a library management system, right? Or a grading system. And in that, there used to be a menu, right? Where you have to enter 1 for this, enter 2 for this, etc. The menus on System 390 used to be one step ahead. You had to figure out a way to scroll your cursor down to the right position on the line and then press some complicated combination of function characters. Right? We can't imagine working with applications like that, but things haven't really got that much better. Anybody here worked with AS400s? Okay. So you'll recognize the screen on the right, that's an AS400 screen. Where at least now you could, that combination of characters, etc., were not that crazy that you had to deal with. But it was still the same. One long list of things, go and select from that. Right? And things got better. We got to client server, graphical user interface, and you got some screens which you can see at the bottom. But still, at the end of the day, what it requires from the user is to painstakingly learn how a system works. And I mean, the Microsoft Office applications or any other Office applications, those menu systems are still intuitive and understandable. There are some ERP applications whose menu systems are so opaque and so complex that users, and who uses ERP systems? People in finance, right? People in manufacturing, people in HR, they are, for them it's a pain. Why do we all keep talking about, when you're doing a large enterprise application, you have to think about change management. Why? Because people hate these menus. People hate these screens. They hate having to relearn, oh my God, now what is the next 20 steps that I need to go through in order to place a purchase order? Right? And oh my God, why do I have to learn it again? So, this is a very key aspect of any enterprise application today, is this menu-driven interface, right? You navigate through a series of steps in order to get a task done. Number one, you have to keep learning and relearning what those steps are. And imagine you go away for a 2-week vacation, come back, you wouldn't remember half the things. Again, you have to like, oh, damn, what was that step I need to go through? The second thing about enterprise applications today is that the logic, what happens after the user navigates through all the menus, painfully enters in all the information at the right places, in the right way, without getting an error, presses OK, then what happens? Right? There is a certain flow that is hard-coded by programmers ahead of time that says, here is the logic that will take place in this particular sequence, right? And it will read data from these data repositories. It will merge that with data being entered in the screen, data being fed from other external systems, and write some data back into the some other database or data store, right? So there is this flow of logic and data, and it is hard-coded ahead of time. Everybody with me till now? This is where we are with enterprise applications as they are today. What about a new way of doing things, really, right? Which we all want to get to, where the interface is conversational. I just say what I want to do and it gets done, right? And it is conversational in the sense it doesn't just give an arbitrary error message. If I'm not giving what it wants, it should tell me, okay, Nick, give me this, right? So a guided experience, a conversational interface, a guided experience, and self-determined dynamic data and control flow. So that the program determines, nobody is hard-coding it in. Program determines while it is running, based on the conversation happening with the user, what is the next step that it has to perform, what is the next piece of data it has to read, what is the next piece of data it has to write, what is the next sort of piece of the conversation that it has to have with the end user. So let me give you an example of such, of what an application like that might look for. So this is an example of something we've built, my team, a lot of them over here, to query about information about a part, right? And you'll notice, I don't know if you've seen this, all bots are extremely gentle and polite. They're just written that way. And humans are like very abrupt in the way they'll respond to and including my children, you should hear how they talk to Alexa, my goodness. So this one says, welcome to our customer care chat. How may I help you today? So the person says, provide information on, very, very abrupt, right? Humans provide information on this, right? I need to get my job done. So it says, here is the part number you asked for. it's actually been superseded by another part number. Now think about what it needs to do in order to tell you that, right? In the background, nobody has told it, right? There is no hard-coded logic that says, go first check if this is the actual part number or there is a new part with a new number available. But it does that and comes back and says, it has been superseded. There is 10 units in our inventory. Price is so-and-so. If you need more information, please let me know. So, as usual, we don't pay attention, right? We won't read, a lot of things written. What is the price? Price, it already told you, but we don't read. That's okay. It doesn't mind. It will come and tell you, okay? It then goes and finds what is the price and tells you that this is the part. Again, it has been replaced by another part, and the price is so-and-so. What is the available inventory? It's been told already, but again, what is the available inventory? It goes and says that there are 10 units. Right? Now, this was about just finding out about a part. Right? And this is a very typical application of placing orders. Right? Happens all the time in pretty much every single company that has a supply chain and a manufacturing process, or even an order book where orders are being placed. Placing an order. So that was the earlier illustrative scenario was for querying about a part. This is about placing an order. So the user says that I'd like to place an order for this particular part, right? The system says, okay, this is a fan sled assembly. We have 2 units in stock. Here is the price. How many would you like to order? I want 3. Obviously, again, not read what is written over there. I want 3, because that's what you came with your mind, right? I want 3. What location do you need it? You provide a location. Then it comes back and says, look, sorry, currently we have only 2. Would you like me to place an order for 2? It even goes to that extent. You asked for 3, but I have only 2. Would you like me to place an order for 2? The user, as usual, is very abrupt and says, no, 1. And then it confirms the order, right? And places the order. So before I go to how does it work, does that give you a sense of the kind of sort of application, interface, and experience that I'm talking about? This experience is not very different. Like right at the beginning, I said, how many of you have talked to your phone or talked to your device at home today? We do this all the time, right? It's a very natural way for us to interact. When we interact with another human being, that is how we interact, right? So that is what we would like to do with our applications as well. And now with large language models, we have the capability to do that. And we'll talk a little bit about architecture and what are the things that are involved over there. And so my gut feel is that within the next year or so, we will start seeing a lot of applications and very large-scale enterprise applications that are going to have this look and feel, right? And it's not just, remember, it's not just about the look and feel. It's about the look and feel that the user experiences, which is conversational, and it's also the fact that it's not hard-coded anymore. In the background, the logic, the sequence of steps, the outputs flowing to inputs is all determined on the fly. And how does that happen, right? So you have the idea of an agent, right, which uses a large language model to reason what actions to take and in which order, right? I use the word reason, but I'll put it in quotes, because reasoning is a human activity. This is a program doing it. We don't have better words to describe what it is doing. That's why you use words which are typically characteristics of human thinking. There's a complicated word to describe that. It's anthropomorphize. I can never say that word without stuttering. Even before the talk, I looked it up once just to get my and say it slowly. If I try to say it fast, it gets ahead of me. But this process of assigning human characteristics to software or to agents is called anthropomorphizing. And when I say it is reasoning, I'm basically doing that. We really don't know or understand what it is doing. In the opening talk earlier today, you heard about emergent properties. This is also kind of emergent property. So the agent, it reasons about the steps that need to be performed, and in performing those steps, it uses a tool or more than one tool. And a tool is basically sort of an atomic function, you can think of it, right? Which takes a specific input, provides a specific output. So for example, math, most large language models are terrible at doing math. But we have programs that do math really well, and they've been around for ages, right? So instead of trying to do math, it's better for a large language model to say, okay, a math step is required, call a tool which does the math and sends the output back, right? And you see the flow which happens here, that the user specifies a task through an interface. The agent decides what tool it needs to use and what input it needs to provide to the tool based on the task that needs to happen. It calls the tool with the specific input, records the observation, history of the tool, the input to the tool, and the output is fed back to the agent, and the agent repeats these steps till it decides, yep, I have enough to now go back to the user, right? So that is the loop that is happening. Now, in technical computational term, we are actually starting to move towards applications having what we call a microservices architecture. You're all familiar with that, right? The microservices are nothing but tools, right? The thinking and the rationale of how to combine microservices, in what order to call them, and how to stream the output of one into the input of other. That is what you don't need to now write explicitly. You can let a large language model reason about it. And of course, there has to be testing, there has to be, all the things that we do with any handwritten code can also be done with these systems to see that it is doing the right thing. Also, we have to be careful about what tools we provide, right? Are there going to be unintended consequences, right? It can't be, in enterprise applications, it won't be generally life-threatening decisions, but, deleting a record in a database can be bad enough. Don't even have to get to the point of threatening anybody's life, but deleting the wrong record in a database also can be bad. So all that testing, guardrails, etc., have to be in place. But this is the whole idea of using tools, reasoning about what needs to be done, using tools, providing inputs, getting outputs, iterating through that process till a task gets complete. So a couple of terminologies that you will see if you deep dive into this area. It's called reasoning and acting. I'm going to close very quickly. So there's a thought, which is going step by step, an action, which is the tool and the input, the observation, which is the output from the tool, and sometimes reflection, thinking about that, right, which is optional. There's this idea of memory, whether it's a short-term memory, where you're giving back the last 5 prompts. Is it long-term memory, which is a summarization of all the prompts? Is most relevant memory, finding only certain prompts to go back with, right? And then the next sort of horizon of this, which is the multi-agent framework, where it's no longer a user talking to an agent. It is agents talking to one another, where you give one agent a role, say, of a stockbroker. and you give another agent a role, say, of a software developer. And basically, you give them a goal. You all talk to one another and create a trading tool or an investment tool for me, right? And then these agents talk to one another, give the prompts, reply to the prompts, perform a task, call a tool, and work together to get to an end goal, which is basically an agent-to-agent communication for solving a meta task. And that is the next generation of products that I'm talking about. So I'll end over there with, again, repeating, looking at applications that you can talk to, and really improving the user experience. B, creating applications that basically write logic on the fly on their own, which reduces the amount of time and effort required to build an application. And 3, using it responsibly and putting guardrails in place so that there are no unintended consequences. And lastly, looking at a future where it's not just users interacting with agents, it's agents interacting with agents. All right, that's pretty much all I had to cover. Happy to take questions. There's a question I can see over there. There's a hand raised over there.
So according to a lot of planning benchmarks, LLMs aren't really great at planning. So how do we trust LLMs to give good plans and good processes to combine microservices? And how do we improve if we cannot trust?
So, good question. But I would ask you to break that down. Yes, LLMs are not good at planning. It is what I said earlier, it's not good at doing basic calculations. But we have software which is good at doing basic calculations, right? Part of planning requires simulation and optimization. It is not good at, but we have software that it is good at doing that, right? But how do we use that software today? We make users go through millions of steps, and I'm exaggerating a little bit, but you know what I'm saying, right? Using planning software today is not easy by any means, right? Because it requires the user to explicitly think through. What are all the steps I should check? What are all the steps that I should simulate? Where should I write an optimization? What is the optimization that I should run? Right? So if you are doing a production plan today, for example, keeping in mind demand, that is signals coming through, supply constraints that are coming through, weather events that are coming through, it's sort of a cognitive overload for users to use the tools that are there. Right? What I'm saying is now you have a system that can potentially, even before the user asks, it can run through multiple different scenarios and then provide a recommendation to the user saying, this is what I think is the best plan with these conditions. What do you think? User might say, oh, but did you consider this? Then it can go and run something else, come back with an answer. Now, from a trust perspective, again, I'll go back to the same testing. Any system you put in place today has to be tested. So create the benchmarks that you would for creating, testing any planning software and apply it over here. Right? All I'm saying is that the math required from a planning perspective, we already have those tools. There's no need to replace them. You continue using them. But you take out the tedium and the complexity and the cognitive overload that humans have to go through to run them, which is what prevents such very powerful software often from being used. Right? And it makes it more readily accessible, approachable, and hence applicable to the business and hence generating results. I hope that addresses the question you're asking. Sorry, there's a question at the back over here. There are questions here. Go ahead. We'll
Hello.
take this one first.
Yeah. So you mentioned that making it a chat based or an intuitive based makes it easier, right? But wouldn't be making the same application again, you know, will that be the same replica of it, but just a simpler version? That's one. The second question is, if we were to do this, our ER diagrams have to be fluid, right? The architecture has to be fluid to adapt new changes to the data or anything for that matter. How would the enterprise adapt such kind of fluidity if there are more uncertainty in the data, right? So if there is a lot of fluid data, you might not get structured output out of it. You cannot take insights out of it. You cannot take decisions out of it. Will enterprise and corporates be open to this idea? Maybe as a POC, we can try it and get succeeded, but at large, at scale, will it be possible?
So, in terms of rewriting the application, look, companies rewrite applications all the time. There are new versions coming out all the time. So, you can make it part of your product roadmap and then see how that can be done. You can do it with specific modules, right? So, there are different ways to plan that out. The second part I don't necessarily agree with because you don't need to change anything in your you keep the database the same. So one of the tools we used, I think there were 12 tools used in what we built over here, if I remember correctly. One of that is a simple query tool. The database remains the same. All it is doing is generating the query on the fly. Right? So you can maintain the structure of your database. You can maintain the functions in the system that you have today. Right? The only thing you are doing is creating a conversational interface that is intuitive and generating code on the fly to use the database which exists today, the table which exists today, and to query it. Right? Sorry, there was a question here.
Uh, One of the key challenges that we see, Rahul, in enterprises is the architecture, right? Cloud-native architecture. People spend a lot of time in designing, using the right patterns, microservices architecture to deployment, cache, everything, the trade-offs that they have to do. Today, we see more of it as Copilot on a programming side. But that graduating to the level of architecting the whole solution, where do you think, what do you think the Gen AI or the overall AI has to do in the architecture space, adding value there?
So definitely two things, right? So first of all, my hypothesis and what I am presenting about today says that the architecture itself is going to change, right? That you move to, and we are doing microservices architecture. Whole idea of microservices architecture is modularization, reuse, things like that, right? There is a calculation that is being done on inventory, for example, in 100 different applications around the company. Why do it 100 times? Do it once and use it multiple times, right? So that will still remain the same, but the architecture of how an application logic is built up might need to change, right? The second part is, even if you continue with traditional architecture, right, how can generative AI help you do that? And we have done some work where we have shown, actually, this is a broader question of the entire software development lifecycle, right? Going from requirements to design to coding to testing to deployment. We have found that at every stage, there are quite a few benefits and efficiencies you get from using large language models, right? And including generating architecture diagrams or reading architecture diagrams. Now with the multimodal vision models that are there, these systems are pretty good at reading these diagrams as well to understand them. Do we have time for one more question? I know time's up. But can we do one more? This gentleman here.
Thanks, Rahul, for the presentation. So my question is, like, as we already started adopting agent-based application, like the one example which you just showed. So, so that is like where we already started adopting the agent-based framework. But what about the multi-agent framework, which you just talk about? What do you think are the interesting use cases or implementation that are there we can do in the industry using multi-frame?
Yeah, it is sort of playing the roles of different agents. See, think about how many people here from manufacturing domain? Raise show of hands. There is this famous thing that happens in manufacturing companies called an SNOP meeting. Do you know this? What an SNOP? Supply and operation planning. You know the purpose of this meeting? For people to sit in a room together and argue about what is the right number. That is a process, seriously. It is, for people who have not seen it, you'll be like, what? This is how they decide how many widgets of something to make? They basically sit and shout at each other till somebody wins. Literally, I'm exaggerating a little bit, they're nice, but the process is a matter of opinion. If we can change that to somebody who's sitting on the supply side, somebody who's an agent who's sitting on the demand side, and those agents can have a rational conversation based on tools, based on data, based on predictions, which are all existing tools, right? And be able to come up with an answer. So that's an example that I would think about. All right, thank you all very much for your patience. You've been a lovely audience. I'm done for now.